Welcome to a new video of BigBlur161. In this occasion I wanted to make a small video to explain what are logic gates. I consider this is the next step we need to take in our way to understand redstone. On a previous video I explained various components of redstone, including some characteristics and uses. Now some of those components will be used in order to build logic gates. So what is a logic gate? A logic gate is a device that, based on Boolean rules, can decide upon one or various input signals what an output signal it will give off. For example, we may have three levers, like you can see here, take them as input signals to a logic gate and it will decide what an output it will give off. On this video we will see the 7 main logic gates, how to build them and how do they work. So let's begin. You can see here on this chest the main components we will be using in order to build logic gates. So let's take them and build the first one. The first logic gate we will see is the NOT gate, also known as the inverter. So what does this mean? This gate has only one input and one output. As we saw in the previous video, if we place a torch on a block and that block is powered, you can see that the torch will turn off. So what the NOT gate does is simply to invert the signal. As you can see here, the input is 0 and the output is 1. At least on digital coding, where 0 means off and 1 means on. In the case where the input is on, then the output will be off. So this small circuit is known as the inverter. The next gate we will see is the OR gate. So in this example we have 3 inputs. Of course they could be 2 or 4 or any number. But if we connect them, this circuit is going to decide if all inputs are turned off, then the output signal will be off. But with only one of them to be turned on, then the output signal will be on. It could be any of the inputs. Of course, the input signals can be any combination. With one of them to be turned on, the signal will be on. Or it could be 2, or it could be all of them. And only if all inputs are off, then the output will be also off. On the other hand, the next logic gate is the gate NOR. We can simply take the OR gate and invert the output signal. What this means is that by default, the output signal is on. But with any of the input signals to be turned on, then the output signal will turn off. So the only way the output is on is if all the input signals are off. As you can see, the NOR gate is exactly the OR gate, but the output signal is inverted. The next logic gate is the AND gate. The only thing we have to do is invert all the input signals, connect them, and invert again the output signal. For starters, we see all the input signals are off. We turn on one of them, nothing happens. Let's turn on another one, nothing happens. But if we turn on all of them, you can see the output signal is also on. So with any of them that remains off, then the output signal will also be off. The only way the output signal is going to be on is if all the input signals are on. This logic gate is very used on security, so in order, for example, to open a door, a permission has to be given off by one of the input signals. Logic gate number 5 is the NAND gate. In order to build this one, we have to take all inputs, invert them all, and simply connect them at the end. You will notice it is exactly the same gate as AND, but we are not inverting the final output signal. We are simply inverting logic gate AND. The only way this gate is going to emit an off signal is if all input signals are on. So if we turn off one of the input signals, the signal is inverted. So the next one is gate XOR. First I want you to see this circuit. Here I investigated how to build a flat circuit of only two inputs. If both inputs are off, then the output is going to be off. If we turn on an input, then the output is going to be on. But if we turn on the other one, the output is off. So the only way the input is going to be on is if only one of the inputs is on. But if more than one of the inputs is on, then the output signal is going to be off. Now how do we build one of these for 3 inputs or more? So let's take our target blocks and build the structure like this. So let's place the inputs up here. Then let's place these slabs. These blocks. And target blocks on the other side. Then let's place these torches. And with redstone connect these 3 lines. On the output, we connect all the 3 lines. Then we return to the front part and build the structure like this. We connect with redstone dust all 3 inputs. A redstone torch goes on the other side. And we connect all 3 ends of the line with this redstone torch. Now that way we have our gate XOR. So we turn on an input, the output is on. We turn on this one, the output is on, and the same thing happens with any other input. But if we turn on all inputs, then the output is going to be off. So what this gate does is that if all inputs are on or all inputs are off, then the output is going to be off. But individually, if any of them are on, with any combination, then the output is going to be on. The final logic gate is XNOR, which is the same gate as XOR, but it will be inverted. So we are going to build exactly the same circuit, with the exception of the output, which will be inverted. And yes, it's exactly the same gate, but the output is going to be inverted. Here we can see all the inputs off, and the output is on. We turn on this input, the output is off. We turn on this one, the output is off. And the same thing happens with all inputs. We turn on 2 of them, the output is off. But if all inputs are on, then the output is also on. So finally what this gate does is that with any input on, or any combination of them except all of them, then the output is going to be off. So the only 2 cases where the output is going to be on is if all inputs are on or all inputs are off. Now, the reason I have all these logic gates displayed like this is that they are really easy to see and easy to explain. But actually, we can make very compact versions of the circuits. For example, here we have our inverter. This one is the OR gate. As you can see, all the inputs are very close together. Or we can even have something like this, where if any input is on, then the redstone lamp is going to be turned on. This one is the NOR gate. This one can be the AND gate. And this one is the NAND gate. Hi, this is post-editing me. I did this video in a very simple fashion in order to be able to explain it and many people can understand it also. We have omitted a lot of information like the symbology of logic gates and truth tables, which can be very extensive and complicated in the way we increase the number of inputs of each logic gate. So I really hope I have made this video very simple and comprehensible. Tell me in the comments if you want to elaborate on this subject or you're not interested in it at all. This has been BeRower161.